Given a function written in equation form, including an even root, we want to find the domain. Number one, we need to identify the input values. Two, since there is an even root, exclude any real numbers that result in a negative number in the radicand. Set the radicand greater than or equal to 0 and solve for x. Number three, the solution or solutions are the domain of the function, and if possible, write the answer in interval notation. For example 4, we're finding the domain of a function with an even root. Find the domain of the function f of x, which is equal to the square root of 7 minus x. So in the upper corner here, the index is even because it represents 2 as the square root of that. So when there is an even root in the formula, we exclude any real numbers that result in a negative number in the radicand. So again, when there is an even root in the formula. So we need to make sure that we're careful of that. Now, whenever that happens, we're going to set the radicand greater than or equal to 0 and then solve for x. Well, the reason why is, okay, let's look at a calculator before we start, just to kind of give you an idea. All right, so if we take, the square root of, let's say 4, we're going to get the answer of 2, so that works. If we take the square root of 0, well, that gives us 0. Now, if we take the square root of, let's say, negative 2, well, it's going to give us an error. So that means that going back to what we plugged in, we can put in 4, we can put everything all the way up until 0. But anything below 0, we cannot include. So whenever you have what's underneath the radical, which in this case is called the radicand, we're going to take what's in the radicand, which is the radicand, and then set that to be greater than or equal to 0. Again, when you have an even root. So now we're going to solve this inequality. So the first thing we're going to do is going to subtract 7 to both sides. And then we have to divide both sides by a negative, which means we need to flip the inequality. So we get x, which is less than or equal to 7. So when we draw our number line, we can plot 7, and we can see that we're going to have a bracket at 7 going towards negative infinity. So when we write out our interval notation, we're going to start with the smallest number, which is negative infinity, and recall that parentheses have to be around the infinity. So we have parenthesis negative infinity going all the way to 7 with a bracket. So now we will exclude any number greater than 7 from the domain. So the answers are all real numbers less than or equal to 7, or parentheses negative infinity to 7 with a bracket. Now, can there be functions in which domain and range do not intersect at all? Well, yes. So for example, the function f of x is equal to negative 1 over the square root of x has a set of all positive real numbers as its domain, but the set of the negative real numbers as its range. So as a more extreme example, a function's inputs and outputs can be completely different categories. So for example, names of weekdays as inputs and numbers as outputs, as on an attendance chart. In such cases, the domain and range have no elements in common.